Hey everybody, in today's video I will be covering learning target 19, which is all about indeterminate limits and then solving these indeterminate limits using L'Hopital's rule. So let's jump in. First question is a multiple choice and asks us to figure out which limit cannot be evaluated by L'Hopital's rule. And we remember from L'Hopital's rule, the definition or of the situation when you want to use it is when you're dealing with lots of infinities, whether it's infinity over infinity, or even 0 over 0, that's indeterminate, or an infinity minus an infinity. But these all, if you think about it, they really don't make sense. Like infinity divided by infinity, it's not 1 because they're both just infinitely large. 0 over 0, you can't divide anything by 0, so it's indeterminate. And then infinity minus infinity, same deals like the division, you don't really know exactly what that evaluates to. Okay, so the way we can go about this is, given a specific limit, we can plug in the value of x that we're approaching and see what we get. So here we're plugging in 7. We will have 7 squared plus 7 minus 56, or 7 squared minus 49. This is equal to 56 minus 56 over 49 minus 49, which is 0 over 0. This is indeterminate, and we go about this by using L'Hopital's rule. So this is not one of our answers. Or not our answer, sorry. Next one, we're going to plug in 0. We have 0 squared plus 2 times 0 over 3 times 0 minus 2. This gets me 0 plus 0 over 0 minus 2, which is 0 over minus 2. And this is fine. 0 over negative 2 just equals 0. We don't have to use L'Hopital's rule. The answer is just 0. So from that, we'll say that this is our answer, but I'll go through the other ones just to provide a little clarity. Plug in infinity, we'll have e to the x, so e to the infinity. That's just an infinitely large number. It'll increase. Same with x squared. We have an infinitely large number squared. Infinity. So infinity over infinity. Got to use L'Hopital's for that one. And then finally, plugging in 0. 1 over 0 is an infinitely large number. And then plug in 0 for sine. We know that sine of 0, actually, sorry, I'll go back a step. We'll have 1 over 0 minus 1 over sine of 0. Sine of 0 is just 0. So we'll have infinity minus infinity, which cannot be evaluated. So we gotta use L'Hopital's. So that hope that makes sense. Our answer is B. The other ones, we get some indeterminate form that we'd have to use L'Hopital's rule to solve. But B, we just get an answer of 0, so we're fine. All right. Now I gotta actually solve these limits using L'Hopital's. Well, probably using L'Hopital's. It hasn't really said that explicitly, but once you plug in our limit, we'll see what happens. So plugging in 0, I get negative 8 cosine of 0 plus 8 over 4 times 0. Cosine of 0 is 1, so we'll have negative 8 plus 8 over 0. That just equals 0 over 0. That's indeterminate, so we need to use L'Hopital's. A notation that we often use when we're going to use L'Hopital's is we'll do the equal sign and then H. H stands for, in this case, like L'Hopital. So we'll rewrite our limit as x approaches 0. Now we need to take the derivative, and we take the derivative of the top and the bottom of this fraction separately. I had a couple people do the quotient rule, but in that case, or in this case, that's incorrect. We want to solve or find the derivative of the numerator and then find the derivative of the denominator separately. So chain rule here, derivative of cosine is a negative sign. So the negative, take that out in front, we'll have a positive 8 sine, negative 7x, and then chain rule, need to multiply that by a negative 7 from the inside. And the derivative of 8, that's 0. Also, had a lot of people make that mistake. Remember, we're taking the derivative of a constant, it's 0. And the derivative of 4x, as I said, we're doing this separately, is just 4. All right. So now we actually want to evaluate this limit. I guess rewriting once more, we'll have negative 56 sine of negative 7x over 4. I plug in 0. So we'll have negative 56 sine of 0 over 4. And sine of 0 is 0. So this answer is 0. Great. Now on to part C. First, we will plug in 1 to evaluate this. We'll have 1 cubed minus 2 times 1 squared plus 1 over 1 cubed again minus 1. So I'll have 1 minus 2 plus 1, 1 minus 1. That's just equal to 0 over 0. Surprise, surprise, we need to use L'Hopital. So down here, I'm going to use that notation again, equal sign with an h above it. Same limit notation, but taking the derivative of the top and bottom separately, we have 3x squared minus 4x over 3x squared. Now we can just plug in 1. So I have 3 times 1 squared minus 4 times 1 all over 3 times 1 squared. We get 3 minus 4 over 3, which is equal to negative 1/3. Cool. I'll go through a little summary of this question again. We want to find the limits that cannot be evaluated by using L'Hopital. And when we use L'Hopital, we're looking for like a 0 over 0, infinity over infinity, infinity minus infinity, some sort of indeterminate form. So in this case, A, C, and D, when we plug in our limit number, we get some indeterminate form. But then when we plug in 0 for x in B, we just get 0, which is fine. In part B, we plugged in 0 for x, and we ended up getting 0 over 0, so we use L'Hopital's. In this case, we took the derivative of the numerator and the derivative of the denominator separately. And using the chain rule and also recognizing that derivative of a constant is 0, we found that the limit evaluated to 0. In part C, it was pretty similar. We got 0 over 0, so we used L'Hopital's. Then taking the derivatives and plugging in 1 for x, we got a value of negative 1/3. So that's that. Hope that makes sense.